Hey, algebra. So here's the do now for today. Identify the point, which is indicated as part of that equation, and also the slope, which is indicated from that equation. You might remember or recognize this is point slope form of a line. And so go ahead and hit pause while you see if you can't figure out the coordinates of that point and the slope, and resume again once you got your answers. All right, so here's what we got. The point is highlighted in green. Both are circled in blue. So inside the parentheses, there where the x is, that tells us where we're going to look for the x coordinate. In point slope form, the equation always has the opposite sign of the actual coordinate. So the equation says +1. We're going to have to change that to -1 right over here. And for the y coordinate, same story. Next to the letter y, the equation says -4, and that is the opposite sign of what we use for the coordinates. So change that to +4 as the coordinate of our point. So -1, 4. The slope is highlighted there in red. It's -2. You might want to write that in fraction form, but it's not required. So slope is -2. All right, so today we take a look at graphing linear inequalities. We started this previously. We're going to continue. So graphing linear inequalities combines these two topics we've learned before about graphing lines and also about graphing inequalities. And so when we combine the two, we take some of these ideas, some of those ideas, we combine it, and it's going to make it more complex. So the same set of principles guides us here. We got 3 steps to graph a linear inequality. First, we need to decide the line style that we're going to use. So we use a dotted or dashed line, whichever you want to call it, if the inequality symbol does not have the underline on it. Right? It does not have the or equal to as part of its name. So it doesn't matter which direction it's pointing, this way, it doesn't make any difference. That's not important for this decision. We just want to know, is there an underline? Is there an equal sign as part of that symbol? And if there's not, then it's a dashed line or dotted. If there is, like these ones I circled in red, those have the equal sign as part of the symbol. We'd call it less than or greater to. We would call it greater than or equal to. Those are we're going to use a solid line. The second part of this is once we know what type of line style, we go ahead and graph that line. So that's step number 2. And thirdly, we need to shade. And so in order to determine where we need to shade, we're going to use a test point. The only rule about a test point is that it can't be on the line. But you can choose any point you want anywhere on the graph, test it out, and find out if it works in the inequality. Does it give you a true statement? And really what that answer is telling you is, does that point, does it work? If it does, then that's the part of the graph that you want to shade. So if your test point is above the line you graph, then you should shade above if it works. And if it doesn't, then you pick your point is in the part where you don't shade. So we can just shade the other part. All right, well, let's take a look at that rather than just talk about it. So previously, we were looking at lines in slope-intercept form and whether that's an equation or an inequality. It's still going to have the m represents the slope, the b represents the intercept. That's what we saw before. One of the other forms that we looked at previously is what we're going to see today, which is point slope form. And so that's what we saw today in the do now. Point slope form. This is for an equation. So if you just imagine that equal sign rewritten as an inequality symbol, we're going to graph a linear inequality. But we want to focus right now on the pieces of the equation where we find information we need. So just like in the do now, those 2 things that are highlighted in green, those give us the 2 coordinates of our point. And it's kind of backwards. I mean, it's not intentional by any means, but it's kind of backwards because the x coordinate is like at the end of the equation, but that's what we have to write first in our coordinates. So always put the x number first. And then the y coordinate is like towards the beginning of the equation, but that's the coordinate we write down last. Okay, highlighted in red, that's the slope. If it is already written as a fraction, then that makes it easy for us to know what's the rise and what's the run. If it's given as a whole number, then you can make it into fraction form by giving it a denominator of 1, which might be more helpful for the purposes of graphing. All right, so let's take a look at an example. I'll just talk about stuff. So here is an inequality based on the same one that we just saw in the do now. Instead of an equal sign, this one has a less than. So y minus 4 is less than -2 parentheses x plus 1. So we've already identified the starting point -1, 4, and the slope is -2. I've written it in fraction form, so I got -2/1. This way we know what the rise and the run are. So before we graph a line on here, the first thing we got to do is decide what type of line style to use. And so we're going to look at this inequality symbol, less than. Okay, we don't care which way it's opening or pointing, but it is not or equal to. Right? It's just less than. There's not an equal sign in part of the symbol, and that means we're going to use a dashed line. I'll go ahead and highlight that to match in yellow. All right, so we're going to use a dashed line, and we're starting at the point -1, 4. So I'm going to go ahead and put a point there at -1, 4. There's my starting point. And then I'm going to use the slope as my directions to get to the next point. So from that green dot, I need to go down 2. Technically, it's the rise, but since it's negative, I know I'm going to go down. So down 2 spaces to the right by 1. And then I'm just going to repeat that same pattern again, down 2 again, and right 1. There's my next dot, down 2, right 1. There's my next dot, so that I have enough dots that I'm confident this is going to be a perfectly straight line. So here's my line drawing tool. I'm going to grab a dotted line and attempt to line that up right through the dots. All right, I was not sure at the beginning, but looks like we got everything lined up. Okay, so here's my line. I've got the correct line style. I've drawn the line in the correct place, and now we have to shade. So from this green line, I could either shade above the line or I could shade below. Let's see, just as an example, let's see what those would look like, and then we're going to determine which one is correct. So if I was to shade below the line, it would look like this. From that diagonal green dotted line I just drew, everything below it, you could think of it as, I mean, it looks like it's to the left, but we don't want to think in terms of left and right. It's up or down, and so this is the below. On the other hand, if I shade above, it's going to look like this. Okay, so which one is correct? Let's go the right direction here. Okay, so let's pick a test point. I would prefer to use the easiest possible test point, which is going to be 0, 0. Because then I get to replace the x and the y with a 0, and zeros make things disappear. So it's going to be the easiest almost all the time. It'd be the easiest test point to use. So this test point is located down from that green dotted line. So really what I'm testing when I use these coordinates is down from the line, is that the correct part of the graph to shade? Okay, that's the question really that I am answering. Is below the correct place to shade? Okay, so the way we're going to find out is by taking that inequality and we're going to replace the x and the y with the coordinates of our test point, which is 0, 0. So I'm going to go ahead and replace the x and the y with zeros. And then we're going to follow the order of operations and evaluate this. Okay, so on the left side over here, 0 minus 4, that's -4, and then my inequality symbol. And then when I get to the right-hand side, I'm going to work inside the parentheses first. So I'm going to leave the -2 here. And then inside the parentheses, 0 plus 1, that's 1. Now I need to multiply -2 times 1, and I will get -2. So is that a true statement? Is -4 less than -2? That's the thing we got to figure out here. So -4, is that less than -2? Negative numbers are confusing a lot of times. So the more negativer it is, the less it is, right? Like -1,000,000 is going to be less than like -2, right? So -4 I mean, it's not negative a million, right? But it's more negative-er. Okay, so that is actually less than -2. So our resulting number sentence is true. -4 is less than -2. So what we found out, now that yellow is not easy to see, but we found out that yes, the test point is in the correct part of the graph where we should shade. So we would shade below that green line because that is the part of the graph where the test point is, and the test point worked. Okay, if we had ended up with a number sentence at the end there that didn't work, then we would know our test point was in the part of the graph where we're not supposed to shade. And that's fine. Right? It's not a matter of like, am I right or not? It's we got to figure out, do I shade here or do I shade there? So this time it turns out we picked the test point was in the part where we do shade. Okay, in the interest of being incredibly thorough, let's take a look at the opposite case. For the same inequality, if we had picked the test point in a different part of the graph, what would have happened? All right, so we already know how to graph this because we just did it a second ago. But what if we'd picked a test point above that green dotted line? So I just put a test point here at 3, 2. So here's my test point right there. Coordinates are 3, 2. And so this test point is located above that green line. And so we're going to use the coordinates 3 and 2 to answer the question, is above the correct place to shade. All right, so we're going to get rid of the x, we're going to get rid of the y, and we're going to replace those with the x coordinate and the y coordinate. And I'm going to just make sure we have enough room here to actually do our work. Okay, so let's start on the left side here. 2 minus 4 is going to be -2, inequality symbol. And then -2, that stays put. We need to multiply, we're going to multiply afterwards. We need to do the inside the parentheses first. 3 plus 1 is 4. And now we're going to multiply. So -2 less than, we multiply -2 times 4, that's -8. We keep getting these number sentences with the negative numbers. It's like, oh man. All right. So is -2 less than -8? Well, they're negatives, right? This is still kind of confusing sometimes. But again, the more negative or something is, the less it is. So is -2 more negativer than -8? No, it's less negative, which means it's actually the bigger number. -2 is the bigger number. So this number sentence is not correct. -2 is not actually less than -8. No is the answer to that number sentence, which means we also answered the question, is above the correct place to shade on this graph? Also, no. Okay, so that's what it's going to look like if we pick a test point that's in the wrong part of the graph for shading. It doesn't mean we messed up. We don't need to like back up and do anything again. We just found out this test point is not in the part of the graph where we shade. So since the test point's above, I'm going to shade the other part of the graph. So the test point's on one side. I need to shade in the other side. Right, and I could scroll down and I could shade in like so incredibly thoroughly like the whole entire graph, but you can't see that anyway. So